Hey everyone, welcome back to my channel. Today we are going to code a Python script which encrypts and decrypts files using AES. I will write the code from scratch, explain every step, and show you how it works to protect your data with a password. We will be using Visual Studio Code, and let's jump straight to it. Before we start building the code, we will need to install a library. And to do that, if you have opened Visual Studio Code, you will need to open a terminal like I've done, and you will need to run the following. You will need to run this. This is a library for AES encryption. If you don't have it, run this in your terminal. And now let's start coding the file AES that I have created. First, we will begin with the imports. We need tools for key derivation, AES encryption, random bytes, padding, and file handling. So I will write the imports and speed through them, and then after I'm done, I will explain them to you guys. Now, this first import here, it will turn our password into a secure key. AES here is for encryption. Get a random bytes gives us a random salt, and pad and unpad, it just handles block alignment, and OS handles or helps us with file operations. As I go on and write the code, I will explain these things more in depth. The first step is going to be creating a function that gets the password from a user, so basically from you. It's a very short function, and I will write it quickly, and it doesn't really need much explaining, so let me get into it. And yeah, this was pretty much it. This prompts for the password and returns it. We will use it for both encryption and decryption as we go on. Now, here we are. We're going to start with the encryption function. The encryption function will take an input file, an output file, and a password. And the password is going to come from this function. The input file is basically the text file just a random text file, and the output file is going to be the encrypted file. Now, the first step in our encryption function is generating the random 16 bytes salt. The way to do that is by declaring a variable named salt, and then using the function that we imported from here, and specifying 16, which stands for 16 bytes. The purpose of the salt is to basically make our key unique. So even if we enter the same password, because the salt is generated randomly, so it's basically random bytes, even if the password is the same, this change in salt is going to basically change our password, make it different, not the same each time. Now we will derive a 32-byte key for AES, which is 256 bytes, using this here. Let me add the comment, which is okay. So the way to do this is we create a variable named key, and then we call the function, this function here. Now, what this function takes is it first takes the password, as you can see here, password, salt, length, and there is the count here. But let's start with the password. So the password is coming from here. And one thing we need to do is, since the password is going to come in as a string, this key, or rather, what we need to put here is we need to transform our password into bytes, not string. So we will need to do encode and then specify UTF-8. Next, we need the salt, as it says here. So the salt is basically the variable that we declared here. Then, the DKLAN. We specify the bytes that we want from the key, right? And as we said here, it's going to be 32. Now, why 32? Well, that's because, so the key length can be 16, 24, or 32 bytes based on the bytes of AES. So if we want AES 128 bytes, we will use 16. If we want AES 192, we will use 24. And if we want AES 256, we will use 32 bytes. And finally, the count, which I'm just going to put it to 1 million. Count basically is we are running a million iterations for security, changing it a million times. So it's different or unique. Next, we need a 16-byte initialization vector for AES in CBC mode. And the way to do this is we declare an IV variable and we use this function here and we specify the number of bytes, which is 16. Now, the IV ensures that the same data encrypts differently each time. So you can think of it as an extra layer of protection. Now we will initialize the AES cipher in CBC mode. And the way to do this is by declaring the variable cipher and going with this function. So first we will add the key, which we created up here. Then we will specify the mode, which, as I said, is going to be CBC. And lastly, we will add the initialization vector. Now, you guys might ask, so what is CBC? CBC mode chains each block with the previous one for extra security. Now, if your question is, what are these blocks? So in AES, a block is a fixed-sized chunk of data, always 16 bytes or 128 bits long. AES processes data in these 16-byte blocks, encrypting or decrypting one block at a time. So basically, if we have a file that's it doesn't matter how many bytes long, it's going to encrypt the information in that file by 16 bytes of blocks. Now we will proceed with the actual encryption of the file. So I'm going to create some try and accept blocks, and here we are going to open the file. So we open the input file and we are going to open it in read binary mode because that's what we want to do. We want to read the input file. And I'm also going to open the output file, but this one I'm going to open it in write binary mode because we want to write the encrypted data or text that we take from the input file. So in the input we are just reading, and in the output we are just writing. So we're going to run a loop, a while loop, and this loop is going to run all the time until this condition is met. So before I get into the condition, let me declare, so we have a chunk, right? We are going to grab the words in chunks, and that chunk is going to be 4096 bytes, or basically 4096 bytes is basically 4 kilobytes. Now, there are two conditions that have to be met. The first one is if the length of the chunk is equal to 0, that means that we will stop the loop, meaning that there are no more text from the input file to be processed or and encrypted. And the second one is checking if the length of the chunk is less than 4096 bytes. If it's less than 4096 bytes, then in AES there is something called padding. So if the chunk is smaller than that this amount of bytes, that means that it's the last one. So we pad it with uh, this thing. Chunk is equal to pad chunk 16. This is basically PKCS7 padding. The way that I can explain padding as simple as possible is this. So we read the input file in 4096 byte chunks, which is a multiple of 16 bytes. For the last chunk, if it's less than 4096 bytes, let's say it's 50 bytes, then we will use the padding. Now, this padding adds a 1 to 16 bytes where each byte is equal the number of bytes added. Example. So if you have 14 bytes of, let's say, 0x0e, that's a byte, to make 50 bytes into 64 bytes, right? So we had 50 bytes, and that's not a multiple of 16. So to make it a multiple of 16, which is the closest one to 50, 64, we basically add 14 bytes with that padding. And this ensures that the chunk can be encrypted by AES, which processes 16-byte blocks. Finally, after writing down these two conditions, we will encrypt those chunks that we grab up here. So to do that, we do ciphertext and we will write it to the output file. After encrypting it, we write it there. And yeah, this is basically our encryption function. This is what it is supposed to do. Let me just fix this one here. This is to catch any exceptions in case an error comes up with the files not being found. Okay, so this was the encryption function. I will write the decryption function pretty fast. I will skip showing it to you guys, and then after I'm done writing it, I will just go through it and explain it, because there's a little bit of difference when it comes to decrypting it. And then I will showcase it to you how it works. Now, before I get into explaining the decryption function, I wanted to let you know about this addition that I made. So before we start reading the chunks, or yeah, before we start reading the chunks from the input file, I want you guys to write the output, the salt and the initialization vector in the output file first, because we will retrieve this the salt and the initialization vector when we decrypt the file, and we need those exact same salt and initialization vectors. That's why it's a good practice to save them if you want to decrypt the file. Now, it's not a good approach to do it as I'm doing it, to save it in the uh, output file, but I'm just doing it this way to demonstrate how it works. I mean, it's not like you're gonna be able to, read them because they're gonna be in binary. But either way, so just write the salt and the initialization vector, and then the rest of the encryption is the same. Now the decryption. So we are opening the input file the same way that I did it in the encryption, in read binary mode. Then I'm retrieving the file, the salt. The salt, as we created it, it's 16 bytes long. So basically, this first 16 bytes of the output file is the salt, and this is just to check if the length is not 16, then there's something wrong with the salt. The same goes for the initialization vector. The next 16 bytes is basically the initialization vector, and after that we have uh, the text, whatever it is in the text file. Okay, so after retrieving the salt and the initialization vector, then we will get the key, because the way that AES works is it encrypts the data and decrypts the data with the same key. So we use the same password that we entered, the same salt, and the same parameters to retrieve the same key. And then we receive the same cipher. And finally, we will open the output file. Here we will read the chunk, which is the same 4096. We will check if it's the end of the file. So if the chunk is 0, basically no more bytes, that means that there's nothing in there. We have decrypted everything. We will decrypt the chunk, and then this might seem a bit complicated, but it's not. So this input file.tel, basically it's a pointer that checks how many bytes have been processed. So we have read the first 16 bytes, so the pointer is pointing to the 16. Then we read the next 16 bytes, which goes to 32 bytes so far being read, and the pointer goes there. So when the pointer is equal to the size of the input file, basically when the pointer is equal to the bytes of the file, which indicates that we are at the end, then that chunk is going to be unpadded, because if you remember in the encryption, we added padding right here. So we need to unpad whatever was padded in the file to make it a multiple of 16. And finally, we will write the decrypted chunk on the output file. Now, the way that this program is going to work is it's going to prompt me to enter E for encryption or D for decryption. When I then I'm gonna use the password over here, this function, to get the password. And after getting the password, if the choice is encryption, then here is the file which I have on the desktop, because this file AES here is on the desktop directory. And keep in mind that the input file needs to also be in the same directory as this file. After declaring the input file and the output file, the names, right? The input is going to be a text and the output is going to be a binary. Then I call the encryption function and then just print out this small prompt. If it's going to be a decryption, then I grab this encrypted file here as the input, and then I create a decrypted file as the output. So let's, oh wait, I will, because I don't have this in the desktop, so I will create this file, I will add some text to it, and I will show you guys before I run it, and then we will see what happens on the output. Now here is the text file. This is also located in the desktop, as you can see here. Now I will go here and I will open a terminal and run this. So let me cd to desktop, and here I will run python aes.py. Now enter E for encryption or decryption. We want to encrypt the file first. So enter the password, I don't know, it can be anything, right? Okay, file input test encrypt has been encrypted to output test encrypt bin. Now let's go to the desktop and see what has come up. Now as you can see, here is the AES file. This is the input test encrypt text, And up here we have the output test encrypt bin file that was created. Let me open it in Visual Studio, even though it's, yeah. Yep, it is nothing, it's just gibberish. So even though we can't calculate the first 16 bytes, somewhere here, in the first 16 bytes we have the salt, and then on the other 16 bytes we have the initialization vector, and the rest is basically just the encrypt test text file. Now, let's proceed to run the decryption function. So, let me run this again, and let's select the decryption function. Now it wants the same password. So I'm going to copy this one here and paste it. So if the password is the same, file output test encrypt.bin has been decrypted to this output test decrypt text file. Now, as you can see here, here is the new file, output test decrypt.txt. If I open it, as you can see, there is not a single difference between the files. We have successfully decrypted the file. This was pretty much it about this video. If you guys have any questions, please let me know down below. Hit the like button, subscribe, and I will catch you all in the next video.